Kia ora again, everyone. Another example of the packing circles work. So this time I've used a rhombus shape. You can see in the top image there, I've shown a picture with my circles inside my shape to prove I could fit them in. And then in the bottom image, there's some proof about the area that the area that shape took up. Remembering again, we're aiming for the shapes that take the smallest amount of area. So to calculate this one, you can see here that I've taken my rhombus shape and I've cut off one end and made a triangle shape there, so I can calculate that area. So we've got a base is 15 and the height from the top, the highest point to the base was 40. So 15 times 40, I worked out that was 600. And then that last step is to divide that by 2. So 300 for that area there of that triangle. And then the same for this other triangle over here. It had the same base, the same height, so the area here was the same. And that left me with a rectangle shape or an oblong shape in the middle there. The length was 55 and the other length was 40 of the other side. So in this case, I can just multiply those numbers together. So I'd go 55 times 40, so that would be 550, 1,000, and 100, 2,200 for that area in there. So I would then add the 2,200 plus 300 plus 300. So my total area would end up being 2,500, 2,800 millimeters squared. So then I could compare the area of this shape to my other two shapes and make a conclusion about which of the shapes I've studied so far is the optimal shape for packing those circles. So I want you to do the same thing. I want you to experiment with different shapes like I have. Maybe start with experimenting with quadrilaterals, four-sided shapes. Experiment with at least 3 like I have here. Once you've done that, go on and experiment with some triangle shapes. And I've put in some links in that slide 3 with some different kinds of triangles to spark your ideas. So see if different kinds of triangles can be optimized to hold on to these circles or to pack these circles. And then go on after you've done that and try at least 3 other polygons. Once again, I've put some links to different kinds of polygons. I think I've put links to pentagons, hexagons, heptagons, octagons, nonagons, and decagons, so you can try any of those out and see if you can just find the shape that is going to best pack these circles. Show your findings in your slide presentation with an image showing that you can fit your circles inside your shape, and also some proof to show that the area you say your shape takes up does do that by showing your calculations. Good luck with that. Really looking forward to your examples, and keep sharing your work with us. Thank you very much.